Hey guys, welcome back to a new video. I finally finished my do-it-yourself lithium iron phosphate power station. Now, a long time ago, Ampere reached out and they wanted me to review their 50 amp hour lithium iron phosphate battery. And I was like, instead of doing a review, how about I turn that battery into a do-it-yourself power station? Because I've had a lot of viewers ask me if you can build your own power station. So here it is. I finally finished it. It has a 500 watt AC inverter on the side. It supports a couple of connections on the front, and it has all the built-in charging. So in this video, let me just give you a brief overview of what this is. I'll kind of show you what it looks like inside. Then what we'll do is we'll talk about the benefits of lead acid versus lithium iron phosphate, because you can actually build this with a lead acid battery. And then we'll do just a capacity test on the battery, see if it actually gets its rated power. And then at the end, I'll kind of just give you a brief overview of how it's put together, and then we'll break down some costs and see if something like this is worth it or if you should just go out and buy something right off the shelf. Now, hopefully you guys are excited to see this. It's been a project a long time in the making just because I've been working on a lot of other stuff. Let's go ahead and jump right into the details of this power station. Now, first I thought I'd take a second to break down the front of the power station. So I have a couple different inputs and outputs, and let me just explain these really quick. So I purchased these Anderson power pole kind of power ports on eBay. I'll include all the parts down in the video description if you are interested in picking up any of these. Now this side here is my charging input. I have a solar charger in here, and basically you can just plug in any solar panel from 20 to 50 volts. So it's nice. You can actually take solar panels in series to get a little bit more power, and this goes up to 300 watts. I have your DC charging in here, which is basically 12 volt car charging, and this will charge at around 120 watts. And then I have AC charging here with this port. What's nice is there's no external charging brick. You just plug it in, and this will charge around 180 watts. Now moving on to the other side of the front panel, these are the outputs for the power station. Now right here I have two direct connections up to the positive and negative terminal of the battery, and these are fused. And I can pull 20 amps out of each of these at the same time, so 40 amps total. Now this battery is a 50 amp hour battery, so you can potentially pull 50 amps, but I just haven't designed that through this wiring. Moving down here, I have a power switch that turns this on, so let me go ahead and turn that on. And then this is basically my USB ports and a voltmeter just to see what the actual battery's at. Now they do have updated versions of these. This is just one I had laying around, but you can actually purchase these with a built-in power switch and USB-C power delivery, which is pretty cool. So you wouldn't even have to worry about this power switch, but I have it here just to save on power because I don't want that running all the time. Okay, so here's a look inside the power station. Now the main thing that's in here is the AC inverter. Now this is a 500 watt pure sine wave inverter from Bestech, and I actually had to remove the aluminum enclosure and I mounted it to this wood frame here. And it's actually really sturdy. It has two AC outlets on the top with two USB ports and a power switch that turns it on. Now, whenever it's turned on, I have this fan that came with the AC inverter, but I just mounted it to this corner screw hole here, and it pushes the air down inside the case, and I can actually feel the air being pushed up outside the case, so I don't have any worries about this overheating. Now, what's nice is the lid will actually come down and set on these two supports, so it leaves a crack for airflow and for your wires to come out if you have them plugged into the AC inverter. Now, in the next portion of the video, what I want to do is tear this all apart. I want to briefly talk about two battery options that you can have in this power station, and then I'll show you how it's put together, the charging setup, and how the AC inverter is hooked up, and then we'll do some testing on the outputs. Now, I briefly wanted to show you two different batteries that you could use for this DIY power station build. Now, these are near the same form factor and they are different chemistry, so let me go ahead and talk about the differences between each one. Now, what's interesting is this is the actual battery that I used in my first solar generator build on the channel that actually got me quite a few subscribers, so pretty interesting that it comes back around. It's bringing back some good memories here. This is a 35 amp hour lead acid battery, and this is a 50 amp hour lithium iron phosphate battery. So let's talk about some of the differences. Now, which one weighs more? The lead acid battery weighs about double of what the lithium battery weighs. So if you're looking for portability, you're definitely going to want to go with the lithium battery. Now, as for available capacity in each battery that you can use, the lead acid battery has about 18 amp hours of capacity because she only discharges around 50%. And the lithium battery can discharge all the way down, and you can get the full 50 amp hours before you damage the cells. So it's interesting that the lithium battery has around 2.7 times the amount of capacity that this lead acid battery has, even though they are the same size. Now, which one's gonna last you longer? Well, the lithium battery can support around 2,000 to 4,000 life cycles depending on how you treat it, and you can get around 300 to 800 depending on how you use this lead acid battery. So the lithium battery will definitely last you a longer time. Now, definitely the lithium battery costs more. It comes in at around $250. And this one comes in at around $80. Now, when I first came out with my DIY solar generator video, lithium was not available and it was extremely expensive. And now the prices have come down so much that it's way worth it to go with a lithium iron phosphate battery like this one here. So I've definitely chosen this one. So let's go ahead and do a capacity test on this to see if we can get a full 50 amp hours. So before throwing this battery into my power station, what I want to do is do a full capacity test to make sure we can get 50 amp hours out of it. Now I've decided to use my battery load tester to discharge this battery at a 0.2C discharge rate, which is going to be right around 128 watts. Okay, so I hooked up the load on the battery load tester. You can see we're discharging the battery at 128 watts. Now it's tracking the time. You can see it's been going for about 1 minute and 46 seconds. This will tell us the watt hours we were able to pull and the amp hours. Now we're hoping for 640 watt hours or 50 amp hours. Let's go ahead and let this run and see what we get. Okay guys, the BMS just shut off the output of the battery. The test ran for about 5 hours and we pulled a total of 51.97 amp hours. Well, now that we know that this battery can pull full capacity, let's go ahead and move forward with the power station build. Okay, so I've taken the main power unit out of the ammo box just so you can see it a little bit better. And let me explain basically how it works. Now, you have this wooden frame and it's held together with these screws and brackets at 90 degrees. And I basically just had to cut it to size so that all these components could fit on it. Now, as for the components I installed in this setup, let me explain why I did each one, because I wanted 3 different ways to charge up the battery itself. I wanted to be able to charge with solar panels, 12 volt DC charging, and with AC charging. So let's go ahead and explain how this works. Now, this top one here is my MPPT solar charge controller. It's a PowerWorks 300 watt charge controller. I've featured this earlier on my channel. This one has an input range of 20 to 50 volts DC. So as long as my solar panels are within 20 to 50 volts, I can charge up the battery. Now, because 12 volt charging is under the 20 volt input, I had to actually take 12 volts and boost it up to 24 volts. So I actually have 12 volts coming in here via this connection, and that goes to the input of the solar charge controller and then out to the battery. So then I can charge with 12 volts and with solar panels. I also wanted the ability to charge with AC wall power. So I have this AC to DC converter down here. Basically 120 volts goes in via this connection here, and then it goes out to the solar charge controller at 36 volts and 5 amps. So I convert 120 volts to 36 volts. That is within the range of 20 to 50 volts on the MPPT solar charge controller. Then it goes out and charges the battery. So I have 3 different ways to charge up the battery with each of these methods here. Now, I briefly wanted to show you guys how it's wired in the back. Now, just to try to explain the principle behind this. For example, I have the AC converter here that puts out 36 volts DC, 5 amps, and that is going into this junction here that goes into the solar charge controller. And then right here, I have my DC to DC converter where I put 12 volts in, and then the yellow wire is 24 volts coming out into that same connection point and then going into the MPPT solar charge controller. And then I have my solar connection here for my solar panels, and that also goes into the MPPT solar charge controller. So 3 different inputs all going to one place: the 36 volt AC to DC converter, the 12 to 24 volt converter, and then actual solar panels all go into the MPPT solar charge controller. And then I have one output going directly to the battery, which is ring terminals to charge up the battery itself. There is definitely going to be some loss here because of all this conversion, but in order to get 3 different charging methods in such a small area, this is the only way that I could think of without kind of designing your own board. So I do feel like this is going to work, but remember, I will have a wiring diagram to explain exactly how these are wired up. Now in this build, I decided to go with the Best Tech 500 watt pure sine wave inverter. All I had to do was take 10 gauge wire in parallel with fuses, and then this connects directly to the battery positive terminal, and then same thing with the negative. It's 10 gauge wire in parallel, and this connects up to the negative terminal on the battery. So connecting up the inverter is probably the easiest step in this whole process. Okay, so here's the back side of the front panel, and let me explain the wiring really quick. So you have two Anderson power pole ports that have 4 wires each. This one on this side is basically the output for the battery. So I have this fused positive line. This is actually 10 gauge wire because the built-in fuse wire is just 10 gauge. And I have ring terminals that connect directly up to the battery. So 2 positives there and then 2 negatives. This is 12 gauge wire, and I have the ring terminals on this end to connect up to the battery. So direct output, very simple, just connects up to the positive and negative connections on the battery. Now, moving down to the bottom, I have my USB port and voltmeter. And basically to drill out that hole, you just need a 1 1/8 spade bit. And you drill it out, and then this pops on through, and you put on a washer on the back. Now, it only needs a positive and negative connection to the battery, so I have those 2 wires here. But I didn't want it running all the time, so I just have this on and off switch that basically disconnects the main positive wire for the USB port, so I can just turn it off to save power. Now down here I have the AC input for my AC charger. I'll explain that a little bit later. And then I have the other Anderson power pole port where I have my solar panel charging cable that goes through that, and then my 12 volt charging cable that goes through that. Now the Anderson power poles basically require a 1-inch spade bit to drill out. So 1 inch for the Anderson power pole, 1 1/8 inch for the USB ports, and for the AC charger, you just have to cut that hole using a sharp knife. Okay, so I'm going to reassemble it here, and I thought I'd show you what it looks like without the battery in here and what connections go where. So I have the main charging of the MPPT solar charge controller just coming out here, and it has a main positive and negative terminal. I have the USB and voltmeter connection here, main positive and negative terminal. I have the AC inverter, main positive and negative terminals. And then I have the actual output of the battery, which is basically 2 positives and 2 negatives that go to the main positive and negative of the battery terminal. So basically it's just a lot of wires that go to the main positive and negative. And you know, you just have to make sure they're all the right length so that you can actually reach where the battery goes. And it's fairly simple. It looks really complicated, but you know, you're just mostly doing positive and negative wires directly to the battery. Okay, so I have the battery installed in the case now. All I had to do was connect all the negative wires to the negative terminal, and then all the positive wires up to the positive terminal, and then it tightens down with a Phillips screwdriver, and I was able to get at least 3 or 4 turns before it tightened down. So lots of bite on the screws. They are pretty long that come included in the case. Now there are these 2 nut covers that go over these 2 terminals here, so let me go ahead and put those on. And there you have it. Everything is hooked up and ready to go. Okay, so I thought I'd do a little bit of testing to show you how everything works. Now I have 2 things plugged into the USB ports. I have this small USB LED light, and then I have this small USB fan. So let's go ahead and turn these on. Now I really like this light. It's super bright, and it barely uses any power at all, and it has an inline power switch so you can turn it on and off. This is great for power outages and for camping. And then I have this USB fan up here. It has 3 speeds, and it puts out a ton of air for what it is. That's low, medium, and high is just blowing air like crazy. So I love this little fan here. But yeah, this is just a great way to show you how the USBs can function. You can also charge, you know, tablets or phones. Sure, they won't charge very fast, but you know, you can definitely charge them off these USB ports. Now the next thing I want to test was actually the AC inverter. Now it's a 500 watt inverter, so you can't really power a ton of things, but this is a really cool heater. It's a 200 watt heater. It's great for heating up a teeny little space. Now I've heard people with teardrop campers, this works really well because the space is so small, and it puts out really good heat. Like I said, 200 watts for what size it is. Then I just have it plugged into the AC inverter up there. And I'm just gonna let it run for a little bit, and I'll check in the temperature on the AC inverter in a little bit, just see if everything's working just fine. Okay, so during this test, I thought it'd be nice to hook up my oscilloscope. So you can see we're getting 114 volts output from the AC inverter. Now swapping my oscilloscope over to look at the sine wave, you can see it is putting out a pure sine wave. It's putting out around 60 hertz, and it does have a little bit of noise on the inverter, but it's not too bad. Okay, so I just turned off the heater, and you can see that it is a pure sine wave with much less noise when there's no load at all. And it's putting out 120 volts basically under no load. So not the best inverter in the world, but it seems to work well. Now my main use for a power station like this is probably to use it while camping and to power a 12-volt compressor fridge. So I just wanted to show you how I plan to hook up my fridge. Now there's no 12-volt socket on this. I just have Anderson power pole connections. So I've ended up building this cable a while back because this is way better for when you're driving, especially when off-roading. This does not come unhooked like a 12-volt socket would. So I have about 6 feet of 12-gauge landscape wiring, and then I basically sacrificed the power cable for this fridge, and I soldered on the power cable here, and then I crimped on Anderson power pole connections here. So this plugs into here, and then this side plugs into the fridge. And then basically whenever you're driving down the road, going over any bumps or anything like that, it's not going to come out of the power station and basically, turn off your fridge. So this is a good way to get around the horrible 12-volt socket if you're trying to power a fridge. Now I do have a video about crimping Anderson power pole connections. Okay, so at the end of the video, I just wanted to kind of compare a little bit between cost and maybe some pros and cons of doing a full DIY build versus buying something off the shelf. Now, the price of this came in around $400 or so for me. I did have some of the components, things like that. But if you go out and buy everything today, because of inflation and everything going up more expensive, this costs around $450. So when you spend $450 on something like this, you kind of have to question, why would you want to do this over just buying something that's cheaper? For example, you can pick up this for around $350, and you can pick up the EB55 on sale a lot of times for $399. But there are some advantages to a full DIY setup. For example, if something breaks, you can basically take that component out and replace it. The other thing is you don't have to build, this full setup. You could maybe leave out the AC inverter, leave out the AC charger, and save quite a bit of money and use this just to run a 12-volt compressor fridge, because you're not going to have any parasitic drain from the direct output of the battery, and then you could have a built-in charger and charge it all up. So this would be a really good option for running 12-volt compressor fridges if you want to save money and take out the AC inverter. Now, the other benefit to this is it's just fun. I really had a good time building this battery, and you always learn more and more as you put a project like this together, because you get to work with the components, see how they fit together, and find a way to get it all to fit inside of a case. So personally, I always get satisfaction, and I feel good when I complete a project like this. So there's a little bit of the pros about a DIY power station. Now let's talk about a little bit of the cons. Now, I wasn't too impressed with the AC charger. It kind of made a lot of noise, almost like it was going to explode. I'm sure it was fine, but it's not, I wouldn't say it's the best solution. I'd probably go with something else if I wanted to do built-in AC charging. The solar charging input, the DC charging input was great. The AC inverter does work pretty good on this, but when you're trying to go super budget, your components may, not work perfectly. Now, when you get something like this, it's kind of just designed and engineered to work well. So you're going to have a good amount of charging rate, especially with the dual charging on the EB55. This takes around 160 watts of solar input, has a 700 watt pure sine wave inverter. Now the inverter in this definitely does better than the inverter in this. There's way less noise on this one here. Now this one does come in a little bit cheaper, and it just doesn't charge quite as fast. You actually have more capacity out of this one, but out of all the 500 watt hour power stations that I've tested, these are the most reliable and had the least amount of issues. So anyway, guys, hopefully you found this video helpful. Let me know what you guys think. Do you want to go with a DIY build and change it up, kind of mix this up, do something else with it? Or do you want to go with something right off the shelf Let me know what you guys think in the comment section below. Also, please give me a thumbs up if you like the video. And like always, I always have all the parts down in the video description if you're interested in building this. And I'll also include my review videos to these two power stations. Anyway, thank you so much for watching. Hope you guys are excited for future content. I got a lot more coming. Thanks for watching. We'll see you guys later.